All right, example 10. Example 10 says S, which is 5, 9, and 11, sorry, and T, which is 11, 1, are endpoints of line segment ST. So if I wanted to, I could draw a diagram of this. I didn't need to because you don't need to draw the diagram to answer the question. But I could if I wanted to. Especially if I want you to have a visual appreciation of what you're doing, I could. But I didn't have to. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11, 1, which would probably put me around here. The next point is 5, 9. Oops. All right. Overestimate my diagram. 8 and 9. All right. 1, 2, 3, 4, 5. Vertical. 9 would put me somewhere around up here. All right, so that's 5, 9. Let me remove this line. So this is S, which is 5, 9, and this is T, which is 11, 1. This is line segment ST. All right, so the first thing we're asked to do is to determine the gradient of line segment ST. So let me ask one more time, guys. Do you expect the gradient of this line to be positive or to be negative? Anybody?
Negative.
Negative, because the line is moving from left to right. The line is sloping down. I'm expecting the gradient to be negative. All right, so the next thing I'm asked to do is to calculate the gradient. The formula for the gradient M is equal to y2 minus y1 over x2 minus x1. For the purpose of the formula, this is my x1, y1, and my x2, y2. So M is equal to y2, which is 1, minus y1, which is 9, over x2, which is 11, minus x1, which is 5. So M, the gradient is minus 8 over 6. And so minus 8 over 6 reduces to minus 4 over 3. So the gradient of this line is minus 4 over 3. The next thing we're asked is to determine the equation of the perpendicular bisector. All right, let's see roughly where the middle is. All right. So I would say roughly the middle of this line is 8, 5. Roughly the middle is 8, 5, which would put it around here. All right, I'm going to remove this line now. Then we're going to do our calculations. All right, so now passing through the midpoint is the perpendicular bisector. So this line here is the perpendicular bisector. It passes through the midpoint of ST, and it meets ST at right angles. This line is the perpendicular bisector. We're asked to determine the equation of the perpendicular bisector. Now, for you to use calculation to determine the equation of a line, you must know the coordinates of at least one point on the line. And looking at this, you have S, M, and T. The only point we know that is on this line is M, and M is the midpoint of ST. So I need to find the coordinates of M. M formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. So M is x1, which is it's what, 5? It's 5 plus x2, which is 11 over 2, comma, y1, which is 9 plus y2, 1 over 2. So this means that M is the point, this is 16 over 2, comma, 10 over 2. So M, the midpoint of the line segment ST, is the point 8, 5. So both observation and calculation agrees that the midpoint of the line is 8, 5. So now from the midpoint, I can then go and determine the equation of the perpendicular bisector. I'm turning the page. So the formula for determining the equation of a straight line is y is equal to m into x minus x naught plus y naught. That's the formula. I need the gradient m is m2 is I think it's 3 over 4. Remember, the gradient of ST is minus 4 over 3. Since the perpendicular bisector is perpendicular to ST, I need to invert the gradient and change its sign. Now, the midpoint is on the perpendicular bisector, and the coordinates of the midpoint is 8, 5. For the purpose of my formula, this is x naught and this is y naught. So y is equal to the gradient, which is 3/4, x minus x naught, which is 8, plus y naught, which is 5. So next, I'm going to remove the bracket by applying distributive law. Distributive law says whatever is in the bracket is multiplied by what is immediately outside the bracket. So this is 3 over 4 times x. So that would make it 3/4 x. Then it's 3 over 4 times 8. 4 into 8 goes 2 times. 3 2s are 6. So this is minus 6. Plus at the end, we have 5. So y is equal to 3 over 4x minus 1, because minus 6 plus 5 is minus 1. So y is equal to 3 over 4x minus 1 is the equation of the perpendicular bisector of ST. So let's go back and just pretty up our diagram. All right, just to indicate that it passes through the point minus 1. Guys, this is the perpendicular bisector of ST. It is a straight line that passes through the midpoint of ST and meets ST at right angles.